Theorem 1 states that two intersecting planes meet in a straight line. And I have here an example of a solid figure, which is a cube. And let us say that this side here is the two planes, which is their intersection is a straight line.
Theorem number 2 states that a plane is determined by a line and a point not on it, two intersecting lines and two parallel lines. Here I have this solid figure which is a cube and I will show it to you. A plane is determined by a line and a point not on it. So therefore, this is a plane. Next is a plane is determined by two intersecting lines. This one line here and this another line. They are intersecting lines, so therefore this is a plane. Next is a plane is determined by two parallel lines. This is the first line and this is the second line, which is parallel to this line. Then it is a plane.
Theorem 3 states that if a line is perpendicular to each of the two lines at their point of intersection, then it is perpendicular to the plane of these lines. I have here a solid figure. Let's say this is the plane. And these two lines here intersect. And I have here another line, which is the point of their intersection. It is supported by a statement: if a line is said to be perpendicular to a plane, if it is perpendicular to every line in the plane passing through its foot.
Theorem 4 states that through a point, there is one and only one plane perpendicular to a line. Here is the example. I have this line here, which can be extended to the bottom of the solid figure. And I have this another two lines here, which are perpendicular to this line. Then, the plane, this plane that is determined by these two lines, is perpendicular to this line. As far as I remember, each of two lines that is perpendicular to the third line at the same point, then the plane of these two lines is also perpendicular to this third line.
Theorem 5 states that through a point, there is one and only one line perpendicular to a plane. I have here an example. This is the plane, the point in which a straight line meets a plane. I have these two lines in here. This is the first line and this is the second line, in which it passes through the foot of this line. So therefore we can say that through a point, there is one and only one line perpendicular to this plane. As we go back to Theorem 3, which states that if a line is perpendicular to each of the two lines at their point of intersection, then it is perpendicular to the plane of these lines.
Theorem 6 states that oblique lines from a point to a plane meeting the plane at equal distances from the foot of the perpendicular are equal, and conversely, two equal oblique lines from a point to a plane meet the plane at equal distances of the foot of the perpendicular. And I have example here. I have this line which is perpendicular to this plane, and another two lines which are oblique to the plane. Remember, a line which meets a plane and is not perpendicular to it is said to be oblique to a plane, or the plane is said to be oblique to the line. And as you can see, this tape here determine the equal distances of these three lines.